Group 6, if you want so you can see more clearly, why don't you grab a seat over at Group 9, or you can stay there, it's your choice, but just, I think it would help you in growing and learning if you move. Alright, please clear your desk of all pencils. Have a colored pencil or a marker out. Once again, I am recording during this block as we go over this to help build your understanding. If you need to watch this to shore up your understanding this afternoon / this evening to study for your test, please do that.
When is the test?
Tomorrow. Remember, we talked about that last week, multiple times throughout the week. Huh? For the most part, yes. Like if I'm trying to remember if there's any concepts that were not on there, but I don't believe so. I am going to show the proficiency scale so in a second, so I'll let you know. Remember guys, one thing I need to emphasize is this. Learning never stops, okay? I have to test tomorrow so that we can cover one short concept left and still review before the final. Show me growth and mastery on the final, and you're going to be fine. So update your knowledge here, update your knowledge after this, and you're going to be good. But there's a few things that we need to update our knowledge on, and we got to make sure that we ask the questions we need to ask. If you do not ask the questions you have, I cannot answer them. I want the best for you, but we have to make sure that we're doing everything we can to be successful there. So, I cannot see a pencil on desk. Council, I need the pencils off your desk. Okay? Need a colored pencil or a marker from the box. Okay? Well, Council, the test is tomorrow. So, what we're going to do is, you do better on the test, this demonstrated understanding grade gets replaced. So, say again.
I'm saying though, like, they still gonna count on me up. I ain't start Friday.
I know, but remember, do better on the test, and you're golden, right? Okay. So, it's about the learning, not a single assessment. Learn from this. With that, we're gonna. Nope, that was messed up. We're gonna go over the demonstrated understanding, and hopefully get a little bit more time to review afterwards. So. Remember, you have 4 proficiency scales for this. The sketching polynomials one, we have the defining and analyzing polynomials. That's all module 1, topic 2. Here's polynomial functions when we start with a table, graph, or the characteristics. And the last one was, I forgot to update the top, but does it say the same one? Hold on. Let me get it right. There should be 2 different ones here, and they are not different. Hold on. This one I already have. This is the one I need. Yeah. Okay. So polynomial starting with an equation. Alright, so let's look again at these topics. Remember, you got to actually study. By the blank faces on some of these, it feels like we did not study. And that's okay-ish, I guess, as long as you study before the actual test. Make sure you know these concepts. But I'm telling you ahead of time, this is what you got to know. I told you what lessons these things come from, so that you can look back at those lessons even. Alright, so from here, the concepts you have to know, and they all kind of go together. We got to know what a quadratic function is, a cubic function, polynomial function, dilations by variable expressions, degree of a polynomial, zeros, factors, fundamental theorem of algebra, multiplicity. That showed up throughout this test, or this demonstrated understanding. Being able to determine the standard form by multiplying linear and quadratic factors, identify the zeros using the zero product property, and determining if a polynomial in standard form and in factored form are equivalent. So those are all things that we have studied in the past that we got to know to be able to be successful here, with determining if the y values are positive, 0, or negative, determine the multiplicity, sketch polynomials when given factored form, and sketch polynomials when given the graphs. All of that was on this demonstrated understanding, right? So learn from it, update your knowledge. Determine the degree in factored form, that was on here. The degree in standard form. General shape of a polynomial based on the equation. Identify relative extrema, that was on here. Identify degree based on the shape, domain range, and intercepts of a polynomial, and then all these terms which are almost exactly the same. The only thing that is new on this one, I believe, is rate of change, and we'll talk more about that in a second. Possible number of x-intercepts based on the degree, number of extrema based on the degree, in behavior. One of the things is we've got to talk about this proper notation based on what I saw from last Friday. Absolute and relative extrema, domain and range, in behavior, degree, polynomial, zeros, roots, and x-intercepts, leading coefficient. I will say I believe this test I brought back a section on vocabulary where I give you 6 terms and you have to illustrate, or you have to define those terms and illustrate them to show that you understand what they mean. So be aware that's coming. While this demonstrated understanding was 3 pages, the test is only 4 pages, and you'll have the whole block, so you'll have a lot more time. Say again, Trey.
We gotta define all those.
Not well. These or these or these were on the last one, right? So I'll give you 6 of them, and you have to define them, give illustrations to really demonstrate that you understand.
So as soon as we walk in, we're taking a test.
Tomorrow, yeah. That's why we're going over this right now.
Sweet.
Got an hour and a half to show you mastery. And this is the last one, starting with a table, graph, or characteristics of the polynomial.
I'm gonna get my other ones tomorrow.
Just so you know, okay. This right here, the average rate of change, this one will not be on the test. We didn't have time to get there. So if you see anything about average rate of change, it's not on there. Sketching a polynomial based on given characteristics, that's not on there. So I will take those out. Everything else we have covered for multiple days on end. So we got to know these things. If we don't, we need to update our knowledge today. All right. First things first, we got to know this right here. I need eyes and ears. Des, what's a way that we can figure out the standard form based on this factored form up here?
What's it? The box area model.
Area model. Remember, that area model is just to help me distribute. If I see a factored form and I want standard form, area model to distribute. Right? The area model, again, is just the distributive property. Now, I need y'all to pay attention to this because some people try to multiply negative 2x minus 4 twice. But this is the function. What I said is g of x is x squared minus x minus 6. G of x is being dilated by negative 2x minus 4 to give us this function right here. So, area model. KK. How many, actually let's remember this. KK, what goes in these sides right here?
Multiplication.
So what we're multiplying, what's another term for what we're multiplying? Say it again, Cam. The factors. Remember, my factors go here on the sides. And what goes in the center?
Box.
What you get from, but what do we get when we multiply our factors? We get which form? Standard form, right? Like that's it. To get that standard form, right? We use our area model to multiply. So, it doesn't matter which order you put it in. The only thing I will highly recommend is put your plus or minus with this number here that threw some of us off. But now we just multiply. Okay? Jacqueline, what's negative 2x times x squared? Say again. So remember, we're multiplying negative 2x times x squared.
Is it negative 2x?
So, how many x's do I have if I do x times x squared? Like a blank one? And then I have a negative 2 here. So it's just negative 2x cubed. Yeah. Because notice, and that's what I was saying a second ago, is I was telling you that g of x is dilated by negative 2x minus 4, and I didn't want that to be confusing. I see that it was confusing for some of us, but g of x was x squared minus x minus 6. And so it's just times negative 2x minus 4. That was it. Okay? Yeah.
You have the which part?
I don't know what a whatchamacallit is.
Oh, okay. Yeah.
Okay. Negative 2x times negative x. Jacaitlin, what do I get from negative 2x times negative x? So we got to know how to get these pieces. Hey, Jacaitlin, come on, stay calm. Look at me. I'm gonna get someone to help you out here, so that we can come back to it. Mason,
2x squared.
positive 2x squared.
Yep,
Okay, why plot positive 2x squared?
because it's two negatives. Two negatives make a positive.
So a negative 2 times a negative is a positive 2.
Say plus 2.
And how many x's do I have? 2, so x squared.
You have to put the positive thing.
Yes, because what we're doing is we're adding and subtracting these terms. And I want to make sure it's clear we notice that we're adding these things, okay?
So you want us to put that on there?
Well,
You want us to put like plus 2x? Because I didn't, but I mean.
you can get it right without it, but I promise you that if you write that, it's going to make it harder to make a mistake, and I want to make it easier to get it right, okay? All right, Caitlin, coming back to you after this one, so make sure we understand. Amari, negative 2x times negative 6. Say again? Say it louder.
I don't know.
You don't know?
No.
Amari, do you know what negative 2 times negative 6 is?
Nope.
You have a calculator, right?
Nope.
Yeah? Negative 2 times negative 6, let's go. What's a negative times a negative?
12.
12.
So positive 12. And Amari, how many x's do I have? How many x's? How many? 1. So it's negative plus 12x. That's it. Good. Caitlin? We got negative 4 times what? Negative, I'm trying to fill in this square, so negative 4 times x squared, so what do I get?
4x
Super close. But how many negatives do I have? Only 1. Remember, if it's an odd number of negatives, it's negative, right? This is understood to be a 1 as well, by the way. Negative 4 times 1 is negative 4. Alright? Trey, next box, next term.
Positive 4x.
Okay? And last term.
24.
Positive?
Yep.
Okay. And notice when we use this area model to help us distribute, we see our like terms right here. And Mason, you don't have to, but this is why I like to do that, so that it's easy to tell that we're adding versus subtracting. And so I have negative 2x cubed. I have negative 2x squared plus 16x plus 24. Now, if you wrote this, you did not get full credit.
Nope,
What's wrong with this?
H of X.
H of x. This is a function. I need both inputs and output. And I did not test this, but this is something that was on a proficiency scale, and we need to know, how could I check to see if this standard form is correct? I graphed this and graphed what else? The original factored form. And how would I know if these are equivalent? They match together, right? They map to each other. What's your question, Trey?
I'm confused how you wrote it.
What do you mean?
You just take these and put them together.
So you see how I circled the like terms? What's negative 4 plus 2? Negative 2. Positive 4 plus 12 is, and then if it's x, it's x. If it's x squared, it's x squared. Just let us like terms,
So
okay?
you just carried the two cube out.
Yeah, there's no like terms for the x cubed, right? So it's just negative 2x cubed.
You should put your like terms together.
Alright, what questions do we have? And so again, we get our standard form inside here. What questions do we have about part A?
Can we leave?
No.
Appreciate it.
want you to be successful. You gotta,
The H part.
because remember, it's a function, right? So x is my input, h of x is my output. I need both inputs and outputs for the function.
So we put
Say
exactly
again?
what you
No,
got.
but then you gonna give me credit.
Right,
I mean, have you shown me some evidence of understanding? Yes. But if you don't have the h of x, you are missing a fundamental piece of it and part of the procedure that is a function is equal to h of x. So you remember, it's not just right or wrong, there's a lot of gray in between. It's how much evidence of understanding did you show me? Okay? Now, there are two ways to answer part B. One of them's quick and easy, super quick. The other one is what I really want and is what's really going to help you review solving quadratics, but how could I figure out the zeros and their multiplicities of h of x? So that's the good way, that's what I want to see. Does anyone know what the easy way is though?
Look at the graph.
Look at the graph, right? Where am I going to see my zeros on the graph? On the x-axis, right? X-intercepts. Now, one thing I need you to be clear of and be careful about is this. -2, 0, that's an x-intercept. But what is the 0?
What?
So x equals -2. Right? The x-intercept is -2, 0. But the 0 is x equals -2. You need to be careful about that detail. Right? This is a 0. What's the multiplicity of that 0 based on the graph? Sure about that?
So we
Two.
know it's 2.
How many times do the factors intersect that x-axis right there? Twice, right? The parabola once and the line once. So that is a multiplicity of 2. That's how we need to write it. Caitlin, you know what my other 0 is going to be based on that graph? I looked at Janiyah and I said Caitlin. That's my bad. Yes, thank you, Caitlin. X equals 3. Janiyah, what's the multiplicity there? Any guesses? So this was before last week, so I know you got to go back a good bit. Remember, this was a multiplicity of 2 because 2 factors intersected there, right?
Oh, so it'd be 1.
That's it. That's all it is. Yeah. What was that? Samesies. All right. Cam, you had another suggestion, though. You said to use the what? I think it was Cam that said it earlier. Zero product property. Now, I need you to be careful. In order to use the zero product property, Sean, what does that equation have to equal? 0. It doesn't right now. So to really show me clear, consistent, convincing evidence of understanding, you got to set it equal to 0, the entire function, or the right-hand side, before you use your zero product property, right? But if I have a product of 0, what do I know about those two factors? At least one of them's got to be 0. So x squared minus x minus 6 is equal to 0. Negative 2x minus 4 is equal to 0. And so, we solve those two equations. Now, this one's nice and easy, right? What am I going to do to get started here, Trey? Add 4, right? How many times do we have a variable there? Only once. So what can I use? Inverses, right? If the variable is only showing up once, it is very easy to just use inverses. There's other times you can, but this is the easy one. All right. KK, you know what I'm going to do next? Divide by what?
2 and 4.
Well, which one am I going to divide by?
Oh. 4.
So divide by 4 like this? Now I want you to remember, this is where a lot of people get tripped up. KK, what am I trying to solve for? KK.
2.
I already know what that is. I want to solve for x. You solve for what is unknown. So I need to get rid of what's happening to that x. What's happening to the x, KK?
It's going to divide.
Not right now, it's not. It's being... Remember, when they're right next to each other like this, that's understood to be multiplication. Because it's being multiplied, what do I need to do? What's the inverse of multiplication? Division, right? That's where the division's coming from. Now remember, I recommend using that reciprocal, the 1 divided by -2. but you can also just divide by -2. And the whole point is, what's -2 divided by -2? 1. And so one of my zeros is x equals -2. Holy crap, is that what we see right here for the line? -2 for the x-intercept? Heck yeah, it is. Kyson, you with us? Okay? Now, I'm going to pull this x squared minus x minus 6 over here, because this is what type of equation? That's quadratic. Can I solve a quadratic in standard form? Heck no. So what do I got to do? There's 3 options.
So we use the, no.
We can use the quadratic formula always, as long as it equals 0. We could try the AC method to factor, and we can try the vertex form. Right? Now, we'll point this out. Vertex form, that's going to be ugly. I don't want to deal with a fraction, so I'm not going vertex form. I would personally factor this. Okay? So,
Instead of doing the quadratic formula?
uh-huh. Because I see right away, what can multiply to give me -6 and add to give me -1? 2 and 3, but I need a -6, and I need to add to -1.
You need a -2.
Does that add up to a -1?
Yes.
Remember, the bigger number is positive, so is it going to be a negative? That's going to be a positive 1. Okay. Does anyone remember what group Julian was in? Julian, your demonstrator understanding is somewhere around the room, though. That's Simone. No one has Julian's anywhere near?
You put it somewhere.
It's right
Oh, and then I collected it because I think
It's with Sean.
it's with Sean. Okay, got it. Perfect. Okay. Yeah. All right, guys, we got to pick it up a little bit so we can finish this. So, next piece, right? Remember, we can factor it. Now, can I use the quadratic formula? Yes, 100%. I'm factoring because I like factoring. It's usually a little bit easier. The zero product property is nice. Remember, what I have is which form? Standard. So where's that going to go? In the boxes, right inside. I've got x squared. Remember, the whole point here was that's what is going to go in these 2 boxes to add up to -x. And so, greatest common factor of x squared and 2x? X. -3x and -6. Can't divide that by 2. So -3. X squared -3x, greatest common factor is x. Greatest common factor of 2x and -6. Not 3, 2, right? So remember, when I divide out the 2, I get the -3. But you can also see it, 2 times -3 is that -6. So, and so when you finish solving it, we get x equals 3. And here we get x equals -2, which again shows x equals 3 with a multiplicity of what? 1. X equals -2 with a multiplicity of 2. So notice, do the graph and the equation tell the same story? Should they tell the same story? Yes. Make sure we understand how to update and show that work. Alright, so let's look at our graph. Some of us did this part pretty well. But I might want to see a little bit more evidence because you had a graphing calculator. So you need to show evidence that you understand it, not just typing into a calculator. So when I look at h of x, where do I know the zeros of h of x are going to be? On the x-axis, obviously, right? But where on the x-axis? Right, remember the x-intercepts, the zeros of my factors are going to be the zeros of h of x. Because what happens when you multiply by 0? You get 0. At least one of them's got to be 0. Alright, so what is h of x going to look like to the left of this dashed line? How am I going to figure this out? Multiply the 2 sets of y values. All of these y values are positive. all of these y values are. And tell me, Trey, what's the positive times a positive? Positive times a positive is positive. So my cubic function, by the way, why am I calling this cubic? Because it's 3 what?
Linears.
Ooh, is it 3 linears?
No.
Three zeros. It's actually a quadratic times a linear, right? X squared times x, those x cubed. Lots of evidence there. All right, so now we got to this 0, right? Positives into the 0, but now we got to look in between here. KK, in between here, this parabola has what kind of values? Are they positive or are they negative?
Oh, negative.
So like, we got to know when I ask what kind of values are. I'm just asking positive and negative because you know the answer. You got to get to the point where you can recognize that on your own. Okay, Julian. I know you didn't get a chance to review it yet, but we're looking at it together. This line right here, positive or negative values?
Negative.
Negative? Alright, and what's a negative times a negative, y'all?
Positive.
Ah, wait, it was positive and then it goes back to being positive?
Yeah.
Does it ever go below the x-axis?
No.
No, because what's happening here? It's a double root, it's bouncing, right?
Good deal.
Alright. And the parabola is positive here, so it's just going to bounce it back up again, right?
No.
No? Why not? So don't forget, there's 2 factors all the way through. The line has what kind of values?
Negative.
Negative. The parabola has positive. And what's a positive times a negative? Notice how I'm showing evidence with multiplying the positives and the negatives, right? Just showing that simple positive times a negative to make it work and have evidence. And if you type it into the calculator, that's what it looks like. Say it again. Okay.
You said kaboom.
I think that was a celebration sound effect.
Good.
That was
Guys, fundamental theorem of algebra. We got to know this one. Council, what does that fundamental theorem of algebra tell us?
maximum number of roots. Zeros.
Actually, it's not the maximum number of roots. It is the number of roots, which is the maximum number of x-intercepts.
Yeah.
How many roots should we have for this function since it's cubic?
3.
3. Do we have 3 roots?
No, we got 12.
Yeah.
Yes.
Yes.
We got 3 roots, right?
Double.
1, 2, 3. But how many x-intercepts did we have? 2, right? So, like the cubic
You delayed it.
has 3 roots matching the degree.
I ain't even understand that question.
That means we don't understand the fundamental theorem of algebra. The number of roots, the number of zeros matches the degree. It's x cubed, so it's got to have how many roots? 3. We got to know that. Fundamental theorem of algebra. The degree matches the number of roots. These are things you can write down, guys. The degree matches the number of roots. I know we spent a while on that one, but we got to move a little bit more quickly. Ask the questions you got to ask. I understand.
Well, you said degree what?
The degree matches the number of roots, right?
We ain't been here a whole hour.
Huh?
We ain't been here a whole hour.
I know. Well, we got 40 minutes to finish going over the rest of this, and that was only question 1 of 15.
Well,
I understand.
Wait.
Now, there's lots of parts to this question, but still. I don't think I did too many other ones that had multiple parts like that. Okay. Number 2, we got to know this one. And some of us crushed it. Some of us made me very, very, very sad. Possible number of extrema. How does the number of extrema relate to the degree?
5, 3, 1, 0.
Where are you getting 5, 3, 1, 0?
I'm supposed to check too, right?
Because they come in pairs.
They come in pairs, but the maximum number of maximum number of extrema is 1 less than the degree.
6.
So 6. So 7 minus 1, right? N minus 1 is equal to
I
6.
said it for 7.
6, 4, 2, 0.
I had that.
So, or 6, 4, 2, 0, because they come in
Pairs.
pairs.
Look.
HR.
Notice it's not just writing an answer, it's understanding why and show me you know why. But that's all you had to say. Right? The extrema come in pairs. The max is the degree minus 1, but they come in pairs.
Do I gotta write all the 2, 4, the 4, 2?
Well, do I just ask for the maximum number of extrema? Or do I ask for all possible number of extrema?
Yeah,
I ask for all possible number of extrema.
yeah.
So Kyson, what do you think the number of extrema would be for B? 3? Is that the only option?
3 and 1.
3 to 1.
Remember they come in what?
Pair.
Pairs.
You know, I mean, -1.
Alright, wait.
Well, can you have a negative number of extrema?
I got a question.
Now,
Well, but if a negative means you don't have it, right? It's taking it away, or you owe somebody. Can you owe somebody an extrema? No, right? So I like the idea of like it could be at that pair, but it can't go below 0. Yes.
So how do you get the 4, 2, and 0?
So remember they come in what?
Pair.
So 6. What's 6 minus 2?
58.
4.
All right. What are your questions about number
That's my
2?
question for
Does that make sense?
Yeah.
Okay. What are your questions at this point?
no,
after that,
we have no
you just
question.
Yeah. I mean they come in what?
Pair.
So every set of 2. Right. So you find your maximum, and they come in 2s after that.
Why we gotta subtract 1 first?
So remember, that was 1, a pattern we discovered, but 2, remember, x squared has how many extrema? How many extrema?
1.
It only has 1, right? X cubed had how many extrema? And so when we explored it in the mathematic, we discovered the pattern that the number of extrema is the degree minus 1. But also remember, Mr. Arliss and I brought it up that to understand why that's the case, you will not be able to do that until you take a calculus class. But calculus will explain why it's the degree minus 1. Okay? So that was a pattern we explored, it's a pattern we discovered, but to understand it you have to take calculus. Alright, we gotta pay attention to this one. Guys, there were multiple ways to know something, but I will tell you this. Hey, I had a lot of people say C on this one. Right away, you should know immediately it could not be C.
Could not.
Why?
Because there's 5
There's 5 letters.
Because the end behavior.
Not just that, there's something else that I looked at.
The end behavior.
Say that again, the what?
Barbecue.
Oh, the end behavior.
The end behavior, guys, the end behavior is what?
It's the same.
It's the same, so what kind of degree does it have to be?
It's gotta be even.
It's gotta be an even degree, right?
Oh.
End behavior is the same. So, same, or is even, sorry. No, the end behavior is the same. So, the degree has to be what?
Even.
Notice it's also both going up, so what would we know about that leading coefficient? It's got to be positive, right? That's not something else that says here, but that is good to note that the leading coefficient is positive. They're both going up. Okay,
Is it
so
4?
why do you think 4?
6.
Why do you think 6?
Because I counted the extreme.
You counted the extrema, right? How many extrema is it? 1, 2, 3, 4, 5. So remember, the maximum number of extrema is the degree minus 1.
It's 4.
So what does n have to equal?
6.
Remember,
Yeah, I said minus
degree,
1.
right, the degree
I add 1.
minus 1, but look, the degree minus 1 is the maximum number of extrema. If you put 4 here, what's 4 minus 1?
58.
Yeah, that's what I thought. Alright. Does anyone know another way you could have known that it had to be 6th degree?
Oh, count the roots.
Yeah, count those roots.
Sure.
This is a multiplicity of what? 1. Multiplicity of? 1. Multiplicity of 1.
0.
What's the multiplicity here?
2.
That's a multiplicity of 2. Notice how it touches barely and then bounces away.
The 3.
And this is a multiplicity of 1. How many roots is that?
6.
So lots of evidence that this had to be a 6th degree polynomial.
Hey.
Hey,
Evidence to prosecute it.
So you want me to write all that down? I couldn't just
So I just gained from all that.
Like you gave me an LE. So like.
hey Mason, since 16 weeks ago, 15 weeks ago, I told you that it is all about your evidence of understanding.
So you need
Could
to
you
look at
guess D correct? Okay, so is that evidence of understanding if all you do is circle an answer?
I can't put no evidence on that.
Now, listen, you don't have to have all of this. Having all of this would be that CCC plus, right? That extra mile.
We ain't doing all that.
But you could have just said, hey, the number of extrema is 5, so it has to be 6 degree. You could have said there's 6 roots, so it has to be 6 degree. Like you could have said either one of those to tell me it had to be 6 degree. Okay? You've got to have evidence of understanding.
What about with a circle, like the little circle?
What do you mean? Like circling those extrema?
Yeah.
I would have to fight to say it's a DE plus or a CE.
CE.
I said I'd have to fight. But hey, listen. It is your job to convince me that you understand.
I just told you.
I know, but you told me you didn't write it down. Okay, then that will be evidence. But you need to convince me. Just circling these is not convincing evidence.
How come?
Because you need to explain how that got you there. That is a small part of it, right?
What the ends to trap 1 to 5.
Then that would give me evidence.
Alright.
Alright, so using the function to the right, I think this is the last one that has multiple pieces to it. So, you'll notice I gave you number 3 before this one because number 3 should help us think through this one. Julian, what degree could this function be?
Like even about 11.
Well, I mean, that's part of it, but I'm asking what is the actual degree? Is it 1st degree, 2nd degree, 3rd degree, 4th degree, 7th degree,
I know it.
3rd degree burn.
6th degree?
Okay.
Hold up. Say again.
I counted the roots on the line and then I counted the actual line thing.
Okay.
What are you talking about?
I'm talking about like, cause what you did on the other one, you put the
Zero.
You talking about counting
Yeah.
0 D?
But hold on, how many zeros do I have?
I think it's 4 degrees.
So that would be what degree if I only
You're
have
not
3 zeros?
imaginary.
3rd degree, but I'd probably have some imaginary, right?
Yeah.
But you can't just guess, but I will point this out. It can't be 6th degree. There's a huge piece of information that tells me it can't be 6th degree. What is it, Trey?
Because the things don't match up.
What do you mean? The end behavior is
They're opposite.
different, right? Julian, we got to know when that end behavior is different, it's got to be what type of degree?
I think that's CE.
It's got to be odd, right? It's got to be odd. Now, there's probably imaginary zeros in there. Mason, come on. Engage with us. Keep that head up. Take those notes. Update your understanding. All right. What did we use on the previous problem to help us figure out the degree? The number of extrema.
Extremas.
How many extrema do we have?
4.
So there are 4 extrema.
I just told you that.
So and n minus 1 equals 4. So n is probably what?
5.
I told you that.
I knew that.
Notice I do say it is probably 5. Technically it could be 7th or 9th, but it is more than likely 5th because there doesn't seem to be a whole lot else going on here. Now, this is where I need us to
Do I
focus.
gotta put problems in?
That would be a higher level of understanding. That would get you to a CCC instead of just a CE. Dog, one word to go from a CE to a CCC. Okay. Part B. Nate. Here I ask you for the combination of real and imaginary roots. That means how many real and how many imaginary? How many real do we have?
3.
How do we know there's 3 real? So 3x intercepts, and by the way, all of those zeros will have a multiplicity of what? 1. It just goes through, right?
1.
And each 0 with multiplicity of 1. So 3 real roots. Is that all my number of roots though?
No,
Yup.
you got two imaginary.
Feel like that too, man.
Unless I got imaginary, right? Council, how will I know if I have imaginary here?
Because you know you got 5 total.
Hey Des, how do we know we have 5 total roots here?
Because we done a scrum, no? Whatever.
Say again?
When you count the roots,
But there's only 3 real roots right there.
it's 2 imaginary.
How do you know there's 2 imaginary?
Because if you say 5, you can't see the other 2.
How do you know there's 5? I didn't say there's 5 zeros anywhere yet.
You say, you just said something about how you know it's
Okay,
5.
but that's because council said there's 5. I'm asking how does he know there's 5?
Degree 5.
Okay, it's 5th degree, so there has to be how many roots?
5.
5.
2 of them imaginary.
So, and 2 imaginary to be fifth degree, right?
Okay, like,
It's simple, man. It's so simple.
if I put an arrow to the thing, would that count?
What's your grade?
That would be evidence showing you know it's fifth degree, right? So guys, update that knowledge.
I forget which one.
All right, y'all kill me on end behavior though. We gotta address this.
Who?
You talking about big bro?
I'm talking about like 75% of the class, 80%
Hey, I
of
know
the
that.
class.
I know.
Look, guys, when we say end behavior, you can say different
It's negative.
and things like that. You can't just say negative, right?
Opposite.
Odd even.
It is opposite. Odd and even is the degree, my guy. Right? That's the degree. When we say end behavior, I told y'all very clearly for 2 or 3 days leading up to this, we have the left hand end behavior and the right hand end behavior. And the notation you have to use is as x approaches something, y approaches something. Yep. On the left hand here,
Negative infinity.
it's going down and to the
Left.
so what is x approaching?
Negative infinity.
Negative infinity. What is y approaching?
Negative.
That's in behavior, guys. That's in behavior. That's what, Yana? What is that? In behavior. Guys, you gotta have the notation for in behavior. Mason, did you get all this perfect? No. Then update your knowledge. Stop putting your head down, my guy.
He counts them.
Right hand in behavior. Right hand is all the way over here. And it's going up and to the...
Right.
So what is x approaching?
Positive.
Positive what?
Positive.
And y?
Positive.
Guys, that's what I mean by in behavior.
Positive. I got
Why you circle mine?
Nate.
Do you want us to write left hand in behavior?
So you don't have to, but would that be helpful for you to focus your attention and helpful for me to really know that you know what you're doing?
Can I just put left, right?
You can, right? But again, left hand in behavior, right hand in behavior, really giving that evidence that you know what's going on, guys. Update your knowledge.
Okay. Oh yeah.
What questions do you have?
I'm ready to this kid.
Good.
I'm not.
He's ready.
I take my kid right now.
I'm ready.
Too far. Too far. Too far.
Okay.
Too far.
Put.
He said he'll take care right now.
I take my kid right now.
Don't reach that story.
Wait. How many questions is there?
Dude, I just have to review.
Okay. Huh?
How many questions is there?
I don't remember exactly, but this is 3 pages. The test is 4, and you have to hold along for it. Jaden, Mason, come on, guys. If you need to stand up and take notes, do it. But we ain't falling asleep as we go over this
If I'm
test.
standing up, y'all should be up.
That's what I'm saying, right?
I'm wide awake.
All right, Sean, give me a heads up. No, here, part A. How many zeros is this function guaranteed to have?
God, dog. Guaranteed.
Guaranteed.
8.
Why 8?
Because it's the highest degree.
Right? Not the highest degree. It is the degree. Remember, the degree
It's the highest.
is the highest power. Now, we need to be careful about this. In what form? Standard form. It's not quite that for factored form. It's only in standard. We're going to see this later. But the highest power in here is 8. And so there are 8 zeros. Now, this is where a lot of you are messing up. What important concept tells you this? What tells us the degree matches the number of zeros? The fundamental
Theorem of algebra.
I'm not even for real.
FDA.
You don't have to have perfect English, but I do want you to explain. Make sure you connect the answers. Degree matches
Highest power.
number of zeros. Remember, the degree is the highest power. But what we're saying with that fundamental theorem of algebra is that the degree matches the number of zeros. Now, one thing that I will give you a heads up is definitely on the test is then the question, how many x-intercepts could this function have?
8.
It could have 8. Any other options?
7.
So the x-intercepts, it could be 8, 7, 6.
5, 4, 3, 2, 1.
4, 3,
2, 1.
2, 1.
Can be 0?
Yes. They can all be imaginary.
Remember remember, imaginary come in what? Pairs, right? Could you have 8 imaginary zeros then?
No.
No,
Yes.
yes,
They come in pairs, right?
yes.
So remember, it could look something like this.
Mhm.
Now, if it was odd degree, can it have 0 x-intercepts?
Yeah.
Yeah.
Remember,
Wait, no.
odd goes in
It's
opposite
an odd
directions.
degree, odd degree.
It has to go from a negative infinity to positive infinity, which means it has to intersect the x-axis how many
At
times?
what point?
What time?
At least once, right? So with odd degree, you cannot have 0 x-intercepts, but with an even degree, you can.
Ten.
With an odd degree, you can. With an odd degree, you have to have 1 x-intercept, but you could have 0 with even degrees.
I'm ready for these.
All right, Janai, we talked about this a whole lot up to this point. Do you know how we can find the maximum number of extrema for this polynomial?
No.
The maximum number of extrema?
We talking to.
We talked about it a little bit earlier. Remember, the max
He talking to me?
is n minus 1, where n is the what?
The power.
The degree.
Oh, the answer right there.
So what's the degree?
8. We talking about
The degree, remember,
Eight.
was
8.
8. So 8 minus 1 is 7.
Yeah.
So how many extrema could it have? It could have 7, 5.
3, 4, 3.
Remember, they come in what?
You ain't even saying right
Pairs.
now.
Okay? Alright. I gotta move a little bit quickly, but I need you to pay attention to this.
Push me too fast, bitch.
Well, this is a review because we spent 3+ weeks on this.
Push on past the limit.
You're not ready. I gotta know review Friday. I gotta get my movie.
Not my fault you weren't here. I
Yes,
recorded the
it
videos.
was the doc. I mean, it did his fault.
He wasn't built for this one.
In behavior. Guys, how many different types of in behavior are there? 2. Sorry.
4.
No, there are 4 types of in behavior. There are 2 ins that we have to talk about. But remember, this is an even degree, so they either have to go both up or both
Down.
Come
down.
on, both up.
And they're both up why? So,
There's a positive.
positive what? Even degree and positive leading coefficient.
Default fish.
So it's got to look like this. Something like this.
Yeah.
Now I have to use my notation. Left hand. As x approaches what? On the left hand side, what is x approaching?
Negative infinity.
It's going to keep going left, right? X goes towards negative infinity. What does y go towards?
Positive infinity.
Keeps going up, doesn't it? Notice, drawing this out, drawing those arrows, is that evidence of understanding? Can I visually see what you're doing? Maybe, definitely, right? You're showing me evidence with this. Does that help you see why I'm getting those answers? So if that helps you see why I'm getting those answers, could that help me see why you're getting those answers?
Yup.
Yup. Evidence of understanding, ladies and gentlemen. Right hand.
Negative and positive.
So on the right hand, what is x going to?
Positive.
Positive infinity. But as it goes to the right, it's also going
Positive.
up. Right? So be careful. Look at those arrows again. Like, look at it. It's there. What questions do I need to answer?
What?
You got negative questions.
Negative questions. I don't think you can have negative.
Whoa.
I mean, I guess technically that would be
Zero
I owe
questions.
you questions.
Yes.
I owe you, what question do I owe you?
No, you don't owe me no questions.
You didn't ask for it.
What does it mean when they say it's doing it? Like, where is it going? Where it going? I'm confused.
X is approaching or going towards negative infinity. On the left-hand side, does it ever quit going left?
No.
If it never quits going left, what's X going towards? That's it. That's all it means. And as X goes to the left, what's Y doing? It's going
Up.
To the right.
up. And if it never quits going up, what's Y going towards?
To the right.
A
To the
positive
to the right.
infinity.
Positive.
That's it.
How do you see?
Mm-hmm.
We're about to talk about it. There are multiple ways to talk about 6.
We can skip 6.
No, we're not skipping 6. There is a question like this on your test.
So why was it?
So really, I'm barbecue.
So let's look at number 6. How can you tell what type of function you have in a table? Find the rate of change, right? That's the first piece that we want to recognize. I'm going to show you 3 different ways to think about it here, because there are easier ways than just looking at the rate of change. But look here, plus 16, no, minus 16, plus 16, plus 12, minus 4, minus 8, plus 24, plus 1, 16. I'll point this out, by the way. You have a calculator to use to help you figure this out. But secondly, you know this is what type of function. Like, big idea. It starts with a P. Polynomial. And does anyone remember what type of rate of change every polynomial has? It starts with an A. It has to have an additive rate of change. The only type that's had a multiplicative was what? Exponential, right? It's polynomial. It has to have an additive rate of change. So let's continue examining and go further. Alright, so plus 32, minus 4, minus 16, minus 4, plus 32,
Plus 16. That's 67. That's 67. I'm pretty sure that's 67.
Pretty sure it's 92.
How you do all that math like that in your head?
Y'all, I'm 32 years old and I've been doing math since I was like a wee little man, alright? Like,
Ancient.
I know, I'm old, right? And I've been doing math for forever. That's how. But you got calculators. Use your calculators.
So you went to school with?
I'm definitely in this game. I know that hurt.
When what?
We went to school with Einstein.
I was just saying, regular ass
I don't know about all that. Notice I keep going. Why am I going to keep going here?
Because we're trying to get a constant.
We're trying to get a constant. Haven't got there yet?
Can you show it the other way? I don't like
Watch
this
the
one.
LeBron.
What
A place called Lamp High School. Montgomery.
What is that?
Montgomery.
How you spell it?
LAMP.
Lamp?
Alright, notice constant here. What is to the left of constant always?
Additive.
This constant additive. Linear. Right to the left of constant is linear. Additive.
That's
What's to the left of linear additive?
Oh, quadratic.
Quadratic additive.
Oh, I do that one.
What's to the left of quadratic additive?
Linear additive.
Cubic.
Cubic additive. Cubic.
Oh my goodness. Now, what I want you to remember, in case you have forgotten here, but this is a cubic additive rate of change. So this linear was x to the first, x to the second, x to the third. So this has to be x to the fourth. So this is a quartic function. Now,
Can I know the other way?
I will show you in a second. Okay? That's one way to do it, right?
Not that way.
Rate of change is really, really, really important.
How you know what's to the left or what?
Notice it's always 1 power higher, isn't it? We talked about that.
Yeah, I noticed that.
X to the first, x to the second, x to the third, x to the fourth.
So what's constant? Constant is x to the x.
X to the 0.
X regular.
Constant is x to the 0. See how the power increases by 1 every time?
Got you.
We're almost there.
This kid
Hold
used to feel like a prison.
Okay. Right here.
You graduated in 2010.
2009.
I got you.
You will.
Wait, was that what?
He graduated.
I want you to notice, not constant, but right here. Hey guys.
Hey y'all, cheer.
Hey, excuse me. Look.
You said no IQ.
What?
Wait.
Constant additive. What's to the left of constant additive? Linear additive. So what type of function is this?
Quadratic.
So I've got a quadratic here. Remember, it's a linear additive rate of change. Here.
Too much.
No, it's not too much, man.
It hurt my
It's what
heart.
we learned before. What's this?
Linear.
No, this one.
Oh, quadratic.
Oh, constant. What you talking about?
That's constant, isn't it? Okay, what's to the left of constant additive? Linear. What's to the left of linear additive?
Quadratic additive.
Hey guys, what do I get when I take a quadratic and multiply it by a quadratic? A quartic and x to the fourth power. It's easier to look at the factors, right? That's a quadratic x squared times a quadratic x squared. And so it's a quartic or x to the fourth.
I would have never knew.
We did.
You gonna show me the easy way?
Now I know.
That one, this is the easier way. The last way I'm going to show you doesn't always work. The last method I'm going to show you doesn't always work.
short and short.
But what if I
Show it.
just circle?
4
4 zeros. Oh, if it's 4 zeros, it's gotta be what degree?
Cute.
Fourth. It's 4 zeros.
Another one falls up.
Now there could be imaginary. So hey, listen. You won't always see all the zeros in the table. There could be imaginary zeros. That's why the zeros don't always work. But that is all telling the same story.
Can I put probably like you did another? Probably.
That would be some evidence of understanding. Using your rate of change is what I want to see. Using your rate of change is what I want to see.
You just showed me a method.
But remember, I literally also just said, Trey, that it doesn't always work.
So what if it does work?
Then cool.
Alright,
But it's not a guarantee. I would check that rate of change. Hey, final detail once again on this. What do you need to do? What do you? What's up, Mrs.
Hey, Jessica.
Did you see? I was just thinking of Trey's name.
Jessica.
Yeah.
Is your friend over here gone?
Yeah.
Gone.
Yeah.
Like deuces, out.
Yeah.
He said he gone.
Well, I knew he was going, but I didn't know he was already gone.
So like the
Hey,
because the seniors are all done. He actually is on a recruiting trip teaching or coaching football at some university. Shorter in Georgia. Yeah.
So I don't guess I can ask him about a kid that might have passed or failed.
I mean, I can text him. I'll text him.
Okay.
Shoot me a text. I know.
Okay.
All right. So, excuse me. Hey, right here. So, again, what is the best way to identify the type of function in a table, Mason?
Quadratic form.
Yeah. What's the best way to identify a type of function in a table? No, that's the easy way that does not always work. Maybe 4. The rate of change, guys. Holy crap. Alright. Finally. Last page. We gotta move quickly. Here.
I know the degree.
What do you think the degree is?
2.
I don't think it is.
The degree in 4. I got the 4.
Remember, what form do we have here? What form? Factored. In factored form, you have to look at the zeros for each factor. How many zeros are in this factor?
2.
How many zeros here?
2. 1.
1 here.
8.
And that matches, look, 1, 2, 3, 4. Right?
My God.
So 4 zeros, 4th degree. Ma'am. Say again. Do I ask you to? You could, Cam, but it's not what's asked. It's just what's the degree. So, you can do that. Hey guys, I gotta finish this so I can make scans and let you do a little bit more practice before the end of class.
Are you taking these?
Yes.
You taking these?
So, what? Hey guys, quickly. I don't have time to go all the way over this, but number 8 does not ask how many zeros. It asks what are the zeros. So, I need to set my equation equal to 0 and then use what? Use that zero product property. And what do I need to do after that?
Find the most consistent.
Well, I need to, but I still need to find the what first? The zeros. Now, I do want to point this out, right? You need to solve these. Linear and linear, easy money. Quadratic, what do you need to do?
You gotta convert
You can factor it, you can go to vertex form, or you can use the quadratic formula. Huh?
Ain't nobody doing vertex.
Okay. Some people actually do prefer it. But now solve.
You use basically the quadratic formula to find h and k, and then you got to plug h and k back in.
This kid know what I'm
Hey, it's your choice. Hey, pause and listen. Okay, so now solve. We don't have time to go through all that, but I will also point out, hey guys, don't you have the graph to be able to check your zeros to make sure you got it right? Holy crap.
That's the one. All of them.
Gee willikers.
Nope, not true.
What?
That's got to be a multiplicity of 2 right
Yeah,
there.
because you got double. Because they bounced up. Yeah.
All right. Hey guys, evidence. We got to think through what we mean by domain and range. Kyson, what do I mean by domain? That's all my what?
Yeah.
Not x-axis, all x values. And so, first off, some of us wrote this down. We've said left and right, but that's just how we find the x values. What would be my minimum x.
Negative infinity to.
Does it ever quit going left?
No.
No.
So wherever they're pointing right there, I can't.
Does it ever quit going right?
No.
So it's going to infinity. I don't know if you've noticed this yet, but do you know what the domain of all polynomial functions is? It has been every time. The domain is always that. The domain is always that because you can substitute any x value in. Notice again, is this evidence that I understand what's going on along with these arrows over here?
Yep.
Okay.
Arrow,
Huh?
kaboom.
Yes. I mean, does it help you understand why I'm putting those answers? Okay, then it's evidence of understanding. Cam,
Can you please explain it?
what?
Cam, we don't
Hey,
have time.
it's all x values. So it's the minimum to the maximum. Does it ever quit going left?
No.
So what's the minimum x?
P-Day,
Negative infinity. Does it ever quit going right?
Nope.
So what's the maximum x?
P-Day.
Positive infinity. So Caitlin, if our domain is x, what's my range? No. Like, what do I? If domain is x, range is y, right? So all y values. Now we still need a minimum always to a maximum. What is my minimum?
Next, man.
How do I need to find that maximum y? Does it continue up for forever?
No.
No.
You can you
Guys,
It's 186.
I gotta use that calculator.
Tell about that calculator.
Calculator, super. You can do some crazy stuff that calculator.
Alright, so what was it? 2x squared
Can't even do all that.
minus x
We said told you.
minus 6, and then x plus minus 2, and then, okay. That's the wrong. What was the equation? Get it right. Is that right? Oh yeah, that's right. That's right.
You got to see
Hey,
it.
just we gonna put some pepper in our stove. We got like 7 minutes.
I'm with you.
XO.
GBGDs.
Y'all write it down, please.
XO, y'all, those 23.
You said she
No.
Hey guys, notice. Look, excuse me. That's that simple of using the calculator to find a maximum.
It really is.
It's just analyze that graph.
But we
So what was my maximum?
186.
186.
0.98.
If you have that decimal, sure, but it's just the maximum y. That's all you need there, guys.
What question are we on?
Number 10.
186.
Go ahead.
Okay? Yes, ma'am. Okay.
You got
Okay.
Oh, for number
Excuse me, guys. We gotta finish going over this.
Gotta finish.
Chill.
Okay, it's gonna be quick.
What?
Number 10 for the Rams, we analyze the graph.
You, well, notice it never quits going down, so the minimum's already negative infinity. The maximum, it never goes above 186. Okay, in behavior. I hope we can do left hand and right hand in behavior at this point. I'm not going to explain it, but I will write it down really quickly.
Yep.
You do need to justify it. Okay? Oh, I forgot the extrema. That was number 12, sorry. So, again, use the calculator, but what is going to be this point up here?
Maximum.
What type of maximum?
Absolute.
So this is a relative and absolute max. What is this point?
Relative minimal.
Relative minimum.
And this point?
Absolute relative maximum.
Okay. So,
What is it?
a relative and absolute max, relative min, relative max. Remember, it's all about where it stops increasing and starts to decrease.
Yes.
Okay? So pay attention to where it changes, increasing and decreasing. So, again, we don't have time to go over all of it. I'm not going to heavily count against you or anything. But what do I ask for in number 13? Oh, by the way, here guys, actually write the points from calculator here. I just don't have time.
What's the point one right?
Would it be infinity to negative 3.75?
So when we talk about domain, first off, domain is always my which values? X. And so increasing, it starts what here? It is increasing. What's the minimum x? Negative infinity. Where does it stop increasing? At that maximum. What is it?
186.
See, is that a domain value?
Wait, what?
Is 186 domain?
No, that's the,
That's the y. It's gotta be,
Oh, negative 3.74.
remember, domain.
I have
Okay. So, I don't have time, but what would this section be?
I can't see.
This section right here?
The y?
But what's going to be happening? It's going to be increasing. Okay? Right here it is decreasing. And that would have been from that negative 3.74 to, where does it stop decreasing? Hey.
Did they talking?
Things about AP.
What they say? I need that, AP.
And you got second,
I
third.
need my AP.
You gotta go through the,
You asked me
cafeteria.
AP. You
Alright.
got to share me.
Hey guys, by the way, how many intervals of increase and decrease are there? 2. So make sure you have both of those in there. Alright, what we're going to have to do, okay, is I'm going to finish going over this last one. I need you to leave your demonstrate your understanding and I'll make scans. You can come back after second block to get it to help you study, okay? I still need to make scans. Just come back after second block. Hey guys, hold on. Excuse me. Hey, sit down.
Now, bro.
We still got one question to go. That's why I don't have time to go make scans. Look,
I'll be here patient.
right here. This was the most difficult question. It required the most, but we need to notice what we're starting with is what function?
A quadratic.
A quadratic. That's a parabola. If you check it, this is going to have the x-intercepts of x equals 5, no, negative 5, and x equals 3. And it's going to be concave up. It's going to have a vertex of 1 comma negative 12, okay? So, I don't have enough space for all that, but negative 5, 3, and I know it's going to be concave up. Actually, it'd be negative 1, negative 12. Actually, so negative 16. Alright, what do I still need to do to be able to create the new function? What do I still need to graph?
You need to multiply.
So that would give me the standard form, but I'm trying to graph it. I'm graphing it off of the factors.
Multiply the quadratic.
Okay, so I need to draw my linear in here. Now I can draw it. Positive times negative is negative. Then I've got these x-intercepts. What's a negative times negative? Positive times negative. And then positive times positive. Notice you could also just look at the end behavior based on the fact that it's an odd degree and what leading coefficient. Well, sorry, a positive leading coefficient. Notice it has to be that end behavior there. Leave your demonstrate your understanding on your desk. Leave the demonstrate your understanding on the desk so I can make scans, come back after second block.
That's messed up.
Let's see what's yours. Come on. Come back after second block. Yeah, just go ahead.
Spot on.